Okay, so here in 8.2, we're going to look at graphing exponentials. Here's a bunch of examples of some exponentials that all have a base of 2. Before we go through and we do this, I do want to remind you of some of the kinds of graphing that we had before. So I'm just going to go back to a new slide. And what I want us to do is I want us to graph y equals square root of x minus 1 plus 2. So I want to remind you the parent function for square root looks like that. So I'm going to move over 1 up 2, over 1 up 2, and then I'm going to sketch in my picture. Now it doesn't have a number out here, so I'm not going to stretch it out. I'm just going to use my normal graph of square root. Now this parent function idea, we're going to do the exact same thing today. The only difference is that our parent functions are going to be things like 2 to the x power or 5 to the x power, or I probably won't give you one this big, 17 to the x power. They're all going to be something to the x power. Now in 8.1 we graphed those a little bit using a t-chart. We're just going to graph them more today, and then we're going to do a little bit of some other stuff. So I've given you a whole bunch of different things to graph here. What I want you to notice that they all have in common is this 2 to the x power. They've got other stuff that's different, but they have all of those in common. That's my parent function for all of these. So I'm going to start by graphing. I'm going to put it right here. I'm going to start by graphing 2 to the x power. That's going to be my parent function. So I'm just going to go through, I like to use -1, 0, and 1, and graph these. So 2 to the -1, I'm going to move it to the bottom because of the negative exponent, is 1/2. 2 to the 0, anything to the 0 power is 1. 2 to the first is 2. So let me graph those three. Okay, so this right here is my parent function. You'll want to graph that first, whatever your parent function is. Something to the x power, you want to do it in a t-chart. Then we can go through and use that to graph any of the rest of these. And I'm going to actually skip this first one. Let's go down to this second one. Now, similar to the square root one I had a second ago with the 1 and the 2, I've got 1 there, 3 here. The one inside the operation tells me my side-to-side move. The one outside my up and down. Remember, inside, opposite of the direction you'd think. So I'm going to move over 1, up 3. Over 1, I'm going to do that with all 3 of my points here. Over 1, up 3. And here is my graph. Now, I didn't make it quite probably as steep as I should have here, but see how I just took that and moved it over and up? Now, a couple of things you want to remember. Your parent functions have an asymptote. When you move your graph up, that asymptote moves up along with it. So you want to make sure you don't cross that asymptote. Now, you don't have to draw it necessarily, but I want to know that you know it's there. So you shouldn't have this crossing. It's going to get closer and closer and closer, but never actually touch. Okay, let's graph another one. Now I've got the -1 and the +3, so I'm still going to move it over 1 and up 3. But before I do that, I need to stretch it out by a factor of 3. Now I'm going to go ahead and erase the blue that we just did, and let's just focus on that parent function. All right, so I'm going to go through and I'm going to start by stretching it out by a factor of 3. We did this a little bit in 8.1. So here I'm 2 away from the x-axis, so 2 times 3 is 6. Here I'm 1 away, so 1 times 3 is 3. And here I'm 1/2 away, so 1/2 times 3 is 3 over 2, which is 1 1/2. Okay, now that's great. That's my taking care of the stretched out by a factor of 3. I still need to move it over 1 and up 3. So over 1, up 3, off my graph a little bit. Over 1, up 3. Just a coincidence I landed on that point. Over 1, up 1, 2, 3. Now I want you to notice moving it side to side, up and down. You want to do that last. Go ahead and take care of any other issues you have. Now that means you may have a couple of graphs on your paper. That's fine. Just make sure I know what your final graph is. So let's do one more of these and then we'll move on a little bit. We're going to do this one right here. Now I want you to notice 4 to the x power, that's my parent function. So I'm going to go ahead and make a little t-chart and graph 4 to the x power. Now I'm going to do that quickly. 4 to the negative 1 is 1/4, 4 to the 0 is 1. Okay, so I'm going to go through and graph these points. Alright, so here's my parent function. I have a few things I need to do here. I need to flip it over the x-axis. I need to move it over 1 and up 2. Remember, I'm going to move it side to side, up and down last, which means first I'm going to flip this. Alright, so I'm 4 away here, so I'm going to flip it so I'm 4 away down there, 1 away, 1/4. Alright, now that's great. Now I'm going to move it over 1 and up 2. So over 1, up 2, over 1, up 2, over 1, up 2. So there you go. There's my final answer. Okay, so we're going to skip this one and let's talk about kind of just a little bit on a different note here. So there is a number similar to pi. You know how pi is 3.14? There's a number that's represented by the letter E. That number, and I had to round it, is 2.71828, and it keeps on going. I had to round it at some point, so I rounded it there. I want to show you how to use E in your calculator. This is a number that came up a lot in science fields, and when numbers come up a lot in science fields, they start giving it an easy way to access. Here's where E is on your calculator. There's actually 2 places. One is right here above the division symbol. So you can hit second divide and it'll bring up the E. Now I want you to notice how when you do that it just brings up the E, no exponents. A lot of times you do need exponents, so there's a second place that the E is on this calculator, and it's right above, it says ln, we'll learn what that means later, natural log, but it's right above that natural log button. So same thing, you hit second, ln, natural log. This one's slightly different because it comes up with your E, but it goes ahead and raises it to a power. A lot of times you need it to be raised to a power, so I find myself using this one more often than the other one. Either one's fine, totally up to you. For those of you who have a different version of a calculator, it may come up like this. They're going to open the parentheses for you. Do make sure you close the parentheses. All right, so let's find a few values. We may not do all of these. If we're looking for e to the 4th, I already have the e to a power in there, so I'm going to put in my 4th. Here's my value. We're just plugging in. That's all. Now I'm going to have to round it a little bit. And let's just do e to the negative 3. All right, so I'm going to use the 1 on the natural log and e to the negative 3. Okay, now the main place that we will use this formula, or this letter, is in this formula right here. Usually it's called the PERT formula, but this formula is when you're talking about interest that's continuously compounded. Now, here's what that means. If you have compound interest, that means they take the interest that you make off of your money you've put in the bank or whatever. They take that and they put it in your account, and from here on out, you make interest on the money you put in and the interest that you made. Now, if it's continuously compounding, that means they do that every moment of every day. Now, they can't physically do that every moment of every day, and that's why they have a formula that helps them to deal with that. So this is called the PERT formula. So you'll probably hear me say that. The reason it's called the PERT is because it looks like the word PERT. Let me just let you know what everything means. The A stands for accumulated amount. It's the amount of money you have accumulated. So accumulated amount of money. The P stands for principal. That's the money you put in an account. So if I put $1,000 in the account, my principal is $1,000. Okay, the E is the number we were just talking about a second ago, the 2.7. The R is rate. And the T, I think you can probably guess, is time. In this formula, it is in years. It's just the way they have it set up. Okay, so that's what everything means. Let's answer one question about this and then we'll end for today. So it says, suppose you invest $1,050 at an annual interest rate of 5.5% compounded continuously. How much will you have in the account after 5 years? Okay, now I'm going to go through and write in what I have. So I have my principal. That's what I put in the account. I have my rate. Now, one thing I think I forgot to mention about the rate is you do want to write it as a decimal, not as a percent. So my rate, I'm going to move my decimal over 2 places and it's 0.055. And I also have my time. So let's go through and let's plug those into the PERT formula. I'm going to use it because it's compounded continuously. All right, I'm looking for how much money I'll have. I put in 1,050. My rate, I'm going to write it as a decimal, for 5 years. Now, pretty much you can just plug this into your calculator as is. So I'm going to go through and put in my 1,050 e to the 0.055 times 5 power. Okay, now I want to give you a heads up on this. If you are a person who has a calculator that the E comes up like this, make sure after you put your stuff in there, make sure you close your parentheses. We don't want the calculator to get confused on whether that 5 is supposed to be up in the exponent or not, because it won't always follow what you mean if you don't tell it exactly. Okay, and then I'll hit enter. So I'm going to round to the nearest penny since we're talking about money. So 1,382.36 cents. That's how much I'll have after 5 years. So you made, $330. So, that's decent. Now, you'll notice we may do a project this semester. I've done it in Algebra 3 in the past. I haven't decided if I'm going to do it with you guys. But you'll notice that you earned some money, but you'll earn a lot more money the more money you invest. The second thing is there's something important about having time for money to accumulate in accounts. So y'all are young. Y'all have an advantage over us older people. Well, I'm not that old. You have an advantage over the older people because you've got a lot more time. So I really would encourage you when you get out of college, start investing money, because the more money you invest early, the less money you'll have to invest over your lifetime. I had a professor in college who told us, when you get married but before you have kids, if you live on one salary, one person's salary, probably both people will work. If you live on one salary and save the rest, you're pretty close to being set for retirement. If you wait, 3 or 4 years to have kids, then you're pretty much set for retirement because you've invested a lot of money. I don't know if that's exactly true, but she has a good point that money you invest early is really, really important. All right, so this is 8.2.